Okay, so thanks very much for joining this session. So this session is session 5AP, and it is an IMS stream. So welcome to the IMS stream. It's called Lessons Learnt in Streaming IMS Data to Modern Platforms, and it will be via Scott Quillisi. And basically, in terms of how we'd like the session to go, if you've got any questions, then please put them through in the chat. Chat and post them to me, and then I can ask them verbally when Scott goes through his presentation. So that's how we'd like that to be done. We've got feedback, so we've got the slide that we have here in front of us has the QR code. So if you do that on your phone, or you can go to the agenda website, GSE, and then for this session, if you actually click on the title of the session in the agenda, then you'll get a link to the feedback session fill out form, and you can post that off. In terms of recording, this is a recorded session, so just bear that in mind, everybody that's on the session now. As I said, if you want to ask questions, then post them in the chat and I'll field them to Scott verbally. So Scott has been basically, I believe his experience is over 40 years in mainframe, and he's been doing a lot on IMS integration, and at the moment he's built up a lot of knowledge on data replication, which is what he's going to talk about, and he's an SME in this field. So without further ado, I'll ask introduce Scott for this session. Over to you, Scott.
Well, thanks, Dom. I appreciate that, the introduction, and welcome everybody. As Dom said, today we'll be talking about the lessons we've learned over the past 12 to 18 months in streaming IMS data to modern platforms. And it really goes past just IMS. It's streaming any kind of legacy data. Hold on just a second. I apologize for that. Okay. Okay. I've got a friend here that is helping present. It's a little bit noisy. Okay. The topics, we'll go through some introductions, highlight some of the lessons we've learned over the last couple of years, recap best practices, review the data capture methods, the common ones, and then discuss, the optimal streaming platform architecture. A little bit about me. You can see by the picture, I'm old, 40-year mainframe guy, spent like most of my career in the database arena, database tools, software development with IBM, and 30 years specifically in the data replication arena. So I was doing some math on that. I can't believe it's been 30 years, but it has. I was thrown into the IMS world out of the gate with IMS 1.2. So that tells you something. It was back in the early 80s. In 2000, we founded SQ Data, a company that did specialized in data replication. The primary reason was IMS. There was severe shortcomings in IMS replication, so that was our start. In 2019, we were acquired by SyncSort, which is now Precisely. And I do spend a lot of time working with customers on mainframe data integration. So what have we learned lately? Well, there's a couple of reality checks. First of all, the Great Divide, and if you've heard me speak before, we'll go through that in a minute. That's a concept I have between mainframe and cloud or distributed folks, is real, and it's growing. The Great Divide is getting bigger. The other reality check is mainframe expertise is in short supply, and IMS skills are they're becoming extinct almost. The skill set is, we knew this was happen. It has happened, or it is happening now. As far as trends go, cloud is king these days. Everything seems to be going cloud now. with the larger companies. The smaller companies have been going, been on cloud for a while. Now we're seeing the large financial, insurance, retail, all going cloud. So we've seen on-premise targets represent less than 10% of the deployments that we've worked with in 2020 and 2021. Application modernization is super hot right now. It was analytics before, and that still happens, streaming for analytics, but now we have this moving off the mainframe push. It's gained serious momentum. We've heard about that too. We're moving off the mainframe. Everybody just jokes, but now the big companies are actually moving in that direction to get off the mainframe. As far as technical, we'll go through this in more detail, but there's some differences. A cloud database can be painfully slow. Scaling for performance and throughput's often an afterthought. And then we're seeing more of the bidirectional replication. So a replication from cloud back into IMS becoming a more common use case. So this is the great divide I was talking about. Initially, this is my slide here. You have the mainframers on one side and the distributed folks, the cloud folks on the other, with a little chasm here. It's moving to this on the right side. It is getting bigger, and I don't see any end in sight. It's just the skill set is diminishing. A lot of people don't understand mainframe, and our goal as mainframers is to help bridge that as best we can. So these are the common questions as a mainframe person you're likely to be asked. What's an IMS root? What's a concatenated key? Just a simple IMS to us, not so much to everybody else. They say copybooks. First of all, what is a copybook? Once they see one, why are they so complicated? Is there an alternative? What are redefines? What are multi-segment layouts? What are packed fields? It's interesting. People tend to be hung up on packed fields. How do you handle packed fields? Well, the tool doesn't do that you're working with, and most tools do handle packed fields. It's really a non-issue. What's a store clock? And what value does it have? It's really important. The store clocks, GMT to nanoseconds, it's a nice way to serialize streaming data. What are the options for updating IMS from the cloud? Now, we won't get into that, but that does come up. That's a different topic altogether, bidirectional replication. How do you know if your IMS databases and target databases are in sync? And that's a classical question. So we won't get much into that, but you do need to have a method of making sure that the sources and targets are in sync. And it's not easy when IMS is the source and your target is, say, a DynamoDB or a MongoDB. It's a challenge, but it can be done. Why does latency vary so much? And that would be the time an update occurs on IMS until it lands in the target. So the goal is sub-second. We need to manage latency expectations because everybody's a little bit different. And then the last one I like is, this is mostly from, say, the cloud teams. Why is the mainframe team so hard to work with? And that is a true statement. In some shops, the mainframe people are very difficult to work with. We as vendors try to bridge that gap, and make it a little less hard to work with. So it's more education. This is where the great divide comes in. Top streaming platforms. What we see, Kafka #1 by far. Everybody seems to be at least familiar with it by now. It's very popular. I don't know of any company of size that has not at least looked at Kafka. Azure Event Hub is Microsoft's cloud version of Kafka, give or take. Streaming platform, that is number 2. Google PubSub, we see a little bit, not as much as you'd think. And believe it or not, MapR Event Store, which is now part of Hewlett-Packard, we see some of that mostly in EMEA, in Europe. We'll see more MapR than we do here in the States. But regardless of which platform you use, the concepts are the same. So as far as interest over time with the streaming platforms, This is over the last 5 years. You can see the blue line is Kafka, the red line is Event Hub, and then the others you can barely see. PubSub comes in, and then MapR is a flat line. Very common. I agree with this. Over the last 5 years, the Kafka has been the more popular option for streaming. And if you go over the last 12 months, you can see Event Hub is picking up steam as well. So you'll see that, especially folks going to the Microsoft, the cloud. For example, Walmart, everybody knows Walmart. They won't go with AWS as a cloud provider for obvious reasons. They're major competitors. So we see customers like that going to Azure. Interesting, but it kind of makes sense. So before the well, over the last 5 years, the primary objective for streaming was for analytics. So, analyzing transactions, workload, customer behavior. This is where the data scientists come into play. But lately, application modernization has taken a front seat to that. It is, as far as differences, latency, absolutely must be near real time. It has to be as low as possible, whereas latency on the analytics can be somewhat flexible. You might be able to live with 10-minute latency. In app modernization, it has to be sub-second. It's mission critical, the streaming, whereas it's not necessarily mission critical. Analytics streams go down for a short period of time. Nobody's going to scream too loud. The targets are modern modern platforms like DynamoDB comes into play, any of the fast databases. The teams are made up of many diverse people versus a few highly specialized folks like data scientists. And again, bidirectional synchronization comes into play. So you can see they're almost polar opposites, but it's still the streaming case comes into play for both. So let's recap best practices at this point. So again, always said, keep things simple. The fewer moving parts, the better. And what we like to say is avoid premature optimization. And what I mean by that is some customers want to scale right off the bat. And they say, well, we'll need 5 of these and we'll need to scale here. And we say, no, let's start with few parts and then scale as required. Keeping that in mind. The second point is minimize mainframe MIPS, not the other way around. There's no reason to do anything on the mainframe that doesn't like transformation or anything that uses CPU. No need to do that if it could be done on a less expensive platform. So in our opinion, IMS CDC streaming should really operate as a high-speed utility, leveraging zip, be very, very fast and efficient, and kind of a set and forget. We've been pretty successful with doing that, and there's multiple tools that allow you to do that. But it really needs to be a high-speed utility as far as the streaming goes. No work, like I said, on the mainframe side that doesn't have to happen there. And then scaling should all be done on the target side. The second part is eventual consistency, and we'll talk about that more in a minute. Understand that there's a concept called eventual consistency. It happens when you're streaming, and how do you work with it? Also, we want to shrink or bridge the great divide as best we can, and it takes a lot of patience for that. A lot of patience. You'll be asked the same question multiple times. I live this every day. We're working with a couple of large app modernization projects right now. And it does get frustrating, so we just try to be patient. And understand also the final solution will consist of multiple components, multiple tools. There's not one tool that will do everything. So you take the best that does a certain function, you go to the next one, and there are multiple tools at the end of the day. This is an example of streaming architecture. Basically, you have a producer on the far left. That would be, say, your replication streamer utility. It goes into what we call a topic, which, if you're familiar with MQ, it's Kafka's version or Azure's version of a queue that are partitioned. Then you have multiple brokers for redundancy. So you'll have different copies of the same data in multiple brokers or instances. And at the end, you have consumer groups. And those are the ones that can pull the data from the topics and then go to analytic platforms or the modernization targets. It's really nice to be able to use the same for everything. Sometimes it's practical, sometimes it's not, depending on the use case. But this is kind of a high level of what streaming architecture looks like under the covers. Now, the streaming model, this really hasn't changed even over the last 5 years. We're finding the more advanced customers have two zones. You'll land the data initially in what we call the red zone. It could be, they could call it the secure zone, but it's an initial landing zone that is highly secure. It's typically on premise in the raw data format. And this is for speed, right? So you have to land the data as quickly as possible as the changes happen in IMS. From there, you can do tokenization for the PII data, HIPAA, any kind of personal information that needs to be tokenized. You do transformation, you do augmentation. You might want to combine it with location information, for example. And then you'll go to one or more green zones. This shows a green zone. This is clean data, ready for a data lake, ready for modernized apps and different consumers. So if this framework's set up, the concept is to do this once and then have multiple consumer groups pull this data. The level of tokenization is really important for app modernization, for example. You might not mask or tokenize as much as you would for, say, analytics. So there's different levels, but you can pick and choose. Once you land the data in the red zone, you're it's very flexible from that point forward. Okay, this is something that really is a reality check. So databases in the cloud, they're highly scalable and very fast for normal transactions. So if you're doing it from your phone, it's a quick single couple of record update in and out transaction, happens very, very quickly and can be highly scaled up to meet thousands of users concurrently. But for batch, it's much slower, like magnitude slower than traditional on-premise. And this is really important. I'll tell you why in a minute. Ping time is the major factor. So normally database servers run in different location or different server than where the apps run. Even if the edge nodes or the instances where containers or VMs are close, ping is still the major factor. It could be 10 times slower than on-premise. So we've seen ping times in some cloud setups where it's 50 milliseconds. And you can calculate your throughput. 50 milliseconds you measure with a calendar. The throughput becomes 20 records a second. And that's unacceptable. You can't do that, especially if you need sub-second latency, unless it's a small customer, but most customers we deal with are not. You have large volume. So you have to consider this for application modernization, especially with the batch window. The batch window doesn't translate well to cloud because of this ping time. So when we see customers that say, well, we want to go IMS to RDS, Postgres in the cloud, direct. And our transaction volume is somewhere in the neighborhood of 500 million updates a day. Well, there's a red flag right there. This is where streaming comes in, and I'll explain that more in a minute. The other thing is security concerns are much higher. So you're going to have an increased level of tokenization, and you're going to have serious resistance connecting to the mainframe from the cloud. It's just that general resistance, and there haven't been any massive breaches yet, but we all know it's just a matter of time before somebody gets in. So you want to make sure that your data is secure as it sits. So if there is a breach for whatever reason, you're not exposed. For, like I mentioned earlier, for higher volume customers, you have to include a streaming component, and it has to be implemented carefully. Just don't slap it in. We see that sometimes it has to be cleaned up. Let's do it right from the start. Okay, key considerations in streaming is performance and throughput depends on the speed of the target. If the tool is working like utility, like we said, the speed of the target dictates performance and throughput. So if you're going to relational in the cloud and you're looking at 20 records a second, you're not going to be able to you're not going to be successful. We assume sub-second latency is required for app modernization. We have customers that want 20 or 30 millisecond latency. Sometimes it can be achieved, depending. Most of the time it can't. You just have to look at sub-second. I'd say we average maybe 100 milliseconds, 200 milliseconds in our deployments. Then you want to determine the level of scaling. So how you do that is take the peak IMS transaction arrival rate, number of CDC records per second, and batch is the one you want to start with. The onlines or the daily small transactions are usually not an issue, it's batch. You want to compare against the speed of the target. So for relational database on-prem, we see an average roughly, those targets can handle 2,000 rows a second. Relational DB in the cloud, it's normally, we can get it to 250 to 500 rows a second. It all depends on that ping time. And so you'd want to, verify that before you, look at scaling. If you use a streaming platform, and it says Slatform, but it's not, it's a platform, 100K messages a second is what we've seen sustained. It could probably go higher, but most people will never get there. But these streaming platform targets can handle a lot of volume very, very, very quickly. The goal is to keep up with the source CDC arrival rate with acceptable latency, usually sub-second. So a slow apply rate, on the other hand, increases back pressure on the mainframe, which results in higher CPU. You want to make sure you don't create back pressure on the mainframe. So a fast target is critical. Okay, IMS capture, there's really two ways to do this, two commercial ways, and the commercial-based products will use one of these two methods. The IMS log capture, which requires the hex 99s. You have a capture mechanism that can monitor one or more subsystems. In a data sharing group, you definitely want a single capture to keep things in order. Then you have a publisher component, and then you have an apply or ingest component that goes into Kafka. The other method is a IMS data capture exit that is synchronous with the application. Does not require the hex 99s. Most of those are written to, or those changes are written to system log streams that are published downstream. Same concept on the right side as far as the ingestion goes. We see most customers use log-based capture now. We have several that don't because of the logging. They don't want to log the hex 99s that you'll see for FastPath. It doubles basically your logging. So they use the data capture exit, and it is synchronous. There's advantages and disadvantages to both. It really depends. We look at that initially during discovery on the customer's use cases. Now, if you see something like this, this logger exit, there's a product or two out there that uses this for log capture. If you see this run and run quickly, it's terrible, significant performance impact on IMS itself. The goal is to be non-intrusive. For high volume IMS, it's a no-go. Just don't even consider it. Don't waste your time. It's a severe choke point, and we've seen it where it brings down IMS. So if anybody has a log capture exit that uses, a log capture method that uses this exit because it is slick, you get to intercept every log message, run. It's just not a good solution. Back pressure, we talked about that briefly. For the mainframe folks, this is your primary objective. You want to make sure that you don't have any back pressure. The major cause of this is the target cannot keep up with the source workload. It increases latency, people start screaming, and it consumes unnecessary CPU, which translates to money. So we want to make sure that we have a fast target to avoid the back pressure. There should be minimal back pressure on the mainframe side. And that's really a major objective from when you're in the architecture construction phase. Here's a sample high performance streaming setup that we use. And there's multiple tools that do this concept. But we found this to be the most efficient. So on the far left side, you've got IMS Capture and Publisher, components that distribute the data initially to what we have, CDC topics on Kafka. This is raw IMS data, no transformation whatsoever. And from here, you can partition multiple partitions. We usually start with, say, 100 or 200 partitions, depending on the workload. From there, you can have consumer groups and scale as required to end up in a data lake or what they call RDS. It's a relational database in the cloud. One important thing to note is that once you go to a streaming target, you are in eventual consistency mode from here forward, even if the final target is ACID, which means it handles commits on a transaction basis. Kafka does not, or the streaming targets do not do that. But we found this to minimize back pressure. It's extremely fast. The initial landing is somewhere in the sub 100 millisecond range on the average. And it provides the best flexibility for scaling on the target side. So it's ideal, for a large volume deployment. And even the little guys, what I say little guys, somebody who might do 2 or 3 million updates a day. Most of the customers that I personally deal with are well over 100 million updates a day. Some are over 1 billion updates a day, with most of that coming from batch. If you don't have a framework like this, you're going down the wrong path. It's going to hurt you. So a little bit about eventual consistency. I know you probably can't read this because I can barely read it, but it shows a lady and her cat's in the tree. A guy walks up and says, "Can you help me? My cat's in the tree. Can you climb up and get it?" Well, the guy, if you see in the middle here, says, "No need." He reaches down to the next frame below him and pulls the cat out, hands it to the lady. She goes, "Wait a second, there's 2. Oh, well, that's temporary, right? So after that slide, you'll see everything sync up. Eventually consistent is like this. It will be eventually consistent. And not like an IMS where you commit, everything's consistent. It will be eventually consistent, and it's usually a few milliseconds, but you have to keep that in mind when dealing with the data. So what we do, or the nice method, and it works, is to do everything on a physical key method. Use physical keys. Transactions can sometimes be grouped, cannot other times. It's a little different, but the concept of eventual consistency must be taken into account because people try to work around that and it just doesn't happen. It just doesn't work. So like I said, it's eventually in sync. Data will, and can and will, it will arrive out of order if you're going across topic partitions. So if you have a transaction that commits at, say, 1400, has 5 updates in it, and they're all in different partitions, it's possible that the last record gets there first. It's just the way the streaming target works. However, within a single partition, order is maintained. So if you absolutely have to have the full transaction context in sequence, then you're going to use a partitioning key for all those records. It could be a transaction ID, is a common one to use. You could use the root key if everything's in the same database record. There's multiple ways to do that, but that's how you maintain order or not. Some people try to use these commits. They'll put a commit event in a separate topic to consolidate the transactions. Well, the concept's okay. 1, it's slow. It's really slow. 2, the commit can show up before the whole transaction's there. How do you know if the transaction made it completely to all the topics? And then there's usually, I've seen exotic deployments where people have pointers to the records in the topics based on offset, which is an RBA in a topic. It's just a lot of extra overhead, and it's not totally 100% reliable to be your complete transaction in one go. So again, process by physical key, making sure you use that key for partitioning, keeps things in order. The other option is to combine the transaction data before writing it to a streaming target. So if your CDC tool can take a transaction and combine multiple updates into a single message, that works as well. So you do that on the front end. The transactions do have to be predictable. There's a lot to that. It sounds easy, but there's some considerations that have to be taken into account. The initial load, don't forget about this. Somebody's going to remind you if you forget. Ideally, you want to use the same frameworks as the CDC streams. So you want to be able to not have to architect separately for the initial load. It should be able to run in parallel with the CDC streams. So what we see, the larger customers again, will run initial loads at the same time they're doing CDC. Now you can go to CDC, separate them by topic. If the tool works like it's supposed to, it will synchronize the initial load with the CDC. So they're in order. We have customers that have, billions of records they need to move. They can't wait 2 weeks or a week to unload all that and into their streaming target. So they'll do it over time. You know, application modernization, yeah, maybe not a good candidate for that, but analytics is. So there's multiple options there. Again, you want to use the same framework as you use for the CDC if possible. It just makes things easier and keeps the moving parts down. Let's see what we have here. It says, okay, it says questions, okay. And to wrap things up, simple, like I said, keep things simple. Simple is good. Minimize the number of moving parts. Scale only is required. Let's avoid the premature optimization. It's unnecessary. We've actually seen people scale up from the start only to descale because it can be faster with fewer moving parts. Push the heavy lifting off the mainframe. You want to minimize the MIPS and CPU usage. The great divide, again, be patient. Try to bridge it if you can. Let's don't stretch it. Understanding that the final solution is going to consist of multiple tools, and there are a lot of tools available, especially in the cloud. And as a mainframer, good news is your skills are becoming more valuable each day. This is really good news. So if you're a mainframe person, job security is not an issue right now, and won't be for the foreseeable future. Trevor, I see you're on here, so I think you could probably appreciate that. You know, mainframer, I mean, you're good right now, but eventually we'll all be retired or worse, and you know, the skills are just diminishing. The kids just don't want to learn it. I say kids, anybody coming out of school or younger than me, which is a lot of people. They just don't want to learn. It's not as exciting, but there's definite job security there. And Dom, that is all I've got, buddy. I've got Q&A time. If you have any questions, anybody, now's the time.
Okay, so thanks very much for that, Scott. I'll just unmute everybody. So if everybody wants to ask a question to Trevor, then please do so. Sorry, to Scott, not Trevor. If Trevor wants to ask a question, then please unmute yourself now. And add Andy, Trevor, you can ask questions to Scott. I mean, what I'd say certainly on, you mentioned about people not wanting to do mainframe skills anymore, but I mean, certainly we've got relationships with our universities, and there's actually we've actually got courses now running with mainframe, and kids are actually you know, so we've done something to address that in the north of England and the UK. So we've got a couple of universities and that are actually doing mainframe degrees, and they're also got placements in industry and in key organisations. But yeah, certainly things like, I'd be interested to know about you're still seeing clients come through for streaming for analytics, presumably. I know you said that it's more for modernization these days, but presumably you're still getting quite a number of clients for the analytics side.
Oh, that's correct. You're right. And it's good that you have that mechanism, Dom, to train up mainframe skills. It's those apps still exist. And even for modernization, somebody has to understand that. A lot of the guys who wrote those apps are gone it's not easy to go into somebody's code, especially when it's COBOL. Nobody knows it. If it's assembler, it's worse. And we see a lot of vintage IMS apps that were written in assembler for speed. I mean, they already were there for IMS because it's so fast, but they wanted a little bit faster, make sure. So they went with assembler. That one is a challenge. And it's just hard to find skill sets there. COBOL, once you learn it, it's not that difficult of a language, but that's a good thing you're doing. We see other people trying to do that, but my take is you just don't see the interest as much. I mean, the kids don't want that. They want the new, and Java kind of not so much, but say a Python and some of these connectors and, they're into the mobile apps and the cool stuff, right? Mainframe's not so cool, but it's you're going to do better career-wise, at least understanding that side, I think.
Sure. Yeah.
But it's a challenge.
Definitely. It has. And certainly it needs addressing in, the number of years that people have tried to invest in doing that and then not been successful. But certainly it's been turning around a bit in the UK for these initiatives that have been done by various organisations. So, it's quite positive now. Obviously, things like green screens with GUI front ends also helps a little bit in that, I think, for some of the newer people as well. So there is that, but certainly for analytics and that, there's still a lot that people probably want to do. And certainly these are a good way of doing it. And, if you wanted to modernize, interesting about the batch as well, because, significantly, quite a lot of clients still have large batch in their windows. So with that would be interesting to see what the performance was with the number of updates. But it sounds like from what you're saying that, you've got over 1 billion updates that account.
Multiple customers with that kind of volume. What we're seeing though, it's a trend. I think you guys will be interested in this, is the traditional batch. People are considering, and I've seen it work in certain cases where they do a mini batch after a transaction. So if you do say an ATM transaction to go get money, it might update 2 or 3 records. You'll update, do your transaction, update your balance, maybe 1 or 2 other updates, really small, compact transaction. But after that is done and that commits, then they run a mini batch behind the scenes, like posting to the account that normally happens at night, for example. And I'm taking the banking or financial industry as an example, but normally at night they have these big posting jobs that go through every transaction and update a lot of different things. That's where most of the volume comes. We have one customer that does over 500 million updates a day at night. Within 6 hours, they do more than most people do in a month. But these little mini batches, it's something to think about, Dom, if you're into the app modernization side, Trevor. It's a little mini batch, it's almost triggered by that transaction. He'll go do all that posting. So your account's being posted, the full posting is happening constantly. That gets around those long, because batch you can't run in the cloud with any kind of performance. I mean, we've seen that. It just doesn't work. So the applications really do have to be re-architected to take advantage of what is available in the cloud. do that asynchronously after the transaction. It's intriguing. So next year we'll have more of those. What people are doing when they move these big apps off.
Okay. So we got any more questions for Scott? So from maybe Andy or Trevor, then take yourself off mute and ask your question.
Yeah, hi Dom. Hi Scott, it's Andy here.
Hi Andy.
Yeah, excellent presentation, Scott. I thought that was fantastic. Yeah, I mean, obviously this is an IMS stream, but this technology exists for any applicable data on the mainframe. So I was just wondering whether this stream might have been more appropriate in one of the other streams, so that we could get maybe a more generic audience.
Yeah, I would say I've always been classified as IMS guy. I guess I'm pigeonholed in that space, but because I've been doing it forever. But you're right, DB2, Z, DB2I, Oracle. I mean, the concepts are well, not so much on distributed, but when you're coming from mainframe or IBMI, these concepts apply across the board. IMS just makes things more complicated because it is more complicated, and VSAM is right there with it. It's a little easier than IMS, but very, very similar. And these vintage apps that people are trying to get rid of are built in the 70s and 80s. We don't see brand new. I don't know of anybody undergoing brand new IMS deployment. We're going to write this and go to IMS with it. I don't see that. But the vintage apps, just very complicated. Space was a problem. You have bits that represent things, bits because of the space. Dom can probably remember that. Although you're a youngster, Dom, compared to me, buddy. But yeah, we see a lot of vintage stuff, and it just is more complicated, whereas relational is not so much. I mean, we see relational streaming more of a commodity these days. The capture methods are open source now. It's not difficult like it would be for IMS and the non-relational databases. But you're probably right, Andy. I agree with that.
Yeah, I mean,
sorry, Dom.
Apologies, Andy, but on this stream, basically the IMS stream, we were given certain slots which were not the full slot. So what I couldn't do is, I was mindful of the fact that this one would probably be good with a joint DB2 session, maybe, for example, and then the audience would have been a bit bigger, but we didn't have any sort of joint sessions that we could do slots for. Because my slots were not very well. With just ones given to me. So, but I'll take that as
it's not a criticism of you or anybody, Dom. It's just a general observation.
But you're right.
Lots of organisations they'll all be looking at application modernisation, and it is a very generic topic that I think a lot of people would have found very useful. Yeah,
and I think. I think Scott's right as well about a lot of new stuff is DB2. So in our space, we've still got a lot of IMS, but in terms of most of the newer things have been written with DB2 tables and things like that. So, but then they're still wanting to do analytics and that kind of thing. So, yeah,
it's we want to simplify it. For example, the format is typically a JSON or an Avro. That lands in these targets, that it makes it generic. And the good news is, with IMS especially, is that JSON is hierarchical, the structures already. It's not like relational where there's no hierarchy, clear hierarchy. Sometimes you can fake it. But with JSON, it can mirror a copybook almost one-to-one, or it can. So it makes it easy. Anybody can consume this data once it's put in the right format. The trick is that utility to put it in the right format with speed. It can't dim lights, right? It cannot dim lights, and it cannot cause extra mainframe MIPS. Capture is not free, but let's don't make it where it's prohibitively expensive.
And does it cope with multiple redefines? I think that was one of your slides. Yeah. You mentioned that on your slide, that presumably you can, because we have a lot of applications that do multiple redefines.
Right. Normally the code, there's the tool should be able to do that. So if you look at the code, You know, if it's an A, use this layout. If it's a B, use this layout, so on. And sometimes there's a copybook within a copybook. Like somebody might have a filler pickaxe 1000 that could be defined by multiple copybooks. So you have to look at the code there or some kind of logic.
Yeah.
And the tool needs to be able to do that. And
yeah, so you're mapping all those scenarios effectively.
Right. Right.
Yeah.
And without mapping, what you really want to avoid, now I'm going to pitch our stuff here, but we don't map. You can, but if you have to get a GUI and map 2000 fields, it's really painful if there's a change. So what we do is automatically generate those target structures based on the copybooks.
Okay.
So it's not field by field stuff right now, but it just makes it so much faster, and you can deploy very, very quickly. So, i.e. the utility, it just, we look at what's out there and what people don't understand, and let's make it easy. For example, redefine fields, right? Which one do I use? It depends if it's numeric or not. I mean, you've been there, it's not exactly straightforward. So we tried to dumb it down a little bit without insulting any of the architects.
Yeah. Okay.
But it's exciting. I mean, it really is. I mean, we're having a good time with it. A lot of big customers. You'd be surprised the number of customers trying to move off the mainframe and who they are, guys. I never would have thought some of these customers are looking at this just because. But it's happening. Are you guys doing that? You're seeing some moving some apps off. I'm sure you are, some of them, but you're not trying to get off your mainframe completely, are you?
Certainly not from where I work. No, it's there to stay. But they've got other cloud things as well that they're doing as well. So
right,
they're doing other apps with it, with cloud stuff, but not exclusively getting off at all. In fact, there's quite a big push to put on mainframe, fully enough.
Mm-hmm.
But it certainly has its benefits in terms of the analytics side, which is where arguably I probably said, well, it's a mainframe session, which if it's IMS, then we could say if we're exploiting the analytics side, then that's whereas I'm always thinking, well, do we allow a presentation to be, if we're supposed to be on a mainframe stream, for IMS or DB2 or whatever, but it's certainly relevant to have that as a topic, even if it was just for for analytics and that, or getting off the mainframe completely. But that's fine. So have we got any more questions? Because what we have is, thanks for this foil. We've got any feedback. So we've had about 6 or 7 people through the course of this presentation. So if you want to have any feedback, then the QR code is there. So Scott's presented that there. So just use the QR code, or go to the GSC website, go onto the agenda, and then go onto this IMS stream, the avocado color IMS stream for this particular session, and just click on the actual title, and then you'll go through to a link to the feedback. So your feedback will be appreciated, and there's also charities that we're promoting as well for national lifeboats, that kind of thing. So without further ado, I'll say thank you everybody for this session. Thanks Scott for doing it in the morning in US time, and thanks everybody who joined this session. I look forward to some of the sessions. We've got 4 sessions next week starting on Monday, so we'd look forward to joining any of the IMS streams. They're the avocado color ones on the agenda, so have a look, and if you're interested, then we'd like to see you next week. But without further ado, I'll say goodbye from me, and thanks very much everybody for joining, and thanks for your contributions, everybody. Virtual clap. Thank you.
All right, guys, take care.
Bye.
Cheers. Thanks.
Thank you.
Bye.
Bye.